A Top Fuel dragster or funny car can blast past 300 miles per hour in less than 4 seconds. And when something fails at that speed, it doesn't fail gently. It explodes. During the 2024 Virginia Nationals, 16-time funny car champion Don Force rocketed down the track at over 300 miles per hour when the engine suddenly detonated near the finish line, the car disappearing into a violent fireball as flames erupted through the body, crossed lanes, and slammed into the concrete barriers while still carrying enormous speed, proving once again that top fuel racing exists in a mechanical environment unlike almost anything else on Earth, where combustion pressure, traction, aerodynamics, heat, vibration, and mechanical stress are all fighting each other simultaneously. At full throttle, a modern top fuel engine produces more than 11,000 horsepower as a massive supercharger, forces compressed air into the cylinders while nitromethane floods the combustion chambers, creating cylinder pressures powerful enough to split metal apart, overheat the clutch intentionally, distort the rear tires under torque, and physically twist the chassis during acceleration, pushing every single component dangerously close to its mechanical limit. Sometimes the system survives, and sometimes it detonates. Modern stars like Brittany Force have pushed top fuel dragsters beyond 340 miles per hour. But reaching those speeds means operating deeper into a region where even the smallest failure can become catastrophic almost instantly, because one failed spark plug, one unstable combustion event, or one fuel system issue can destroy the entire engine before the finish line. The roots of this danger stretch back decades to a moment that changed drag racing forever when Don Garlits suffered a devastating transmission explosion at Lyons Drag Strip in 1970. Shrapnel tearing through his front-engine dragster and severely injuring his foot, leading him to realize that engines were becoming so powerful that front-engine dragsters would eventually become death traps, a realization that directly created the rear-engine top-fuel dragster design still used today.
Dan Wilkerson smokes the tires, Beckman's on and off the throttle, and for the 300th time, Don Force Racing will celebrate a Nitro Funny Car victory.
Don Force, your 300th win in funny car. Don Force Racing. John, did you ever imagine this was ever possible?
Well, I wished I would have won it, but I wasn't driving. But Beck and Proc and Brittany, they all do a great job. And Robert and myself picked Beckman because we saw what he could do, and we put him in the seat, and boy, he's right in the heat of battle, so I love him, and congratulations, Fast Jack.
Unlike a normal performance engine built to survive for years, a top fuel engine is built to survive for roughly 4 seconds, and that changes everything. Under the body sits a 500 cubic inch supercharged HEMI V8 that runs on nitromethane instead of gasoline. And nitromethane changes the chemistry of combustion itself because it already contains oxygen within its molecular structure, allowing the engine to burn dramatically more fuel per cycle than gasoline ever could, releasing enormous amounts of energy while also generating far greater heat, pressure, and stress on every moving component. At full throttle, these engines can consume fuel at nearly 100 gallons per minute, comparable to the flow rate of a commercial fire hose, while the supercharger forces compressed air into the cylinders at roughly 60 to 70 pounds of boost pressure, creating more than 8,000 pound-feet of torque trying to twist the crankshaft apart almost instantly. The crankshaft experiences such violent forces that teams expect internal damage after every run, which is why crews completely tear the engine apart after nearly every pass, replacing pistons, inspecting bearings, changing spark plugs, checking valve springs, rebuilding the clutch, and analyzing every major component because the stress experienced in less than 4 seconds exceeds what many road cars endure across thousands of kilometers.
NHRA stands for National Hot Rod Association. There's a number of different categories. In the funny car category, we go 0 to 1,000 feet in under 4 seconds at over 330 miles an hour.
Side-by-side racing, 330 miles per hour, 10,000 horsepower, less than 4 seconds. There's nothing like it.
Part and rebuild it in about 30 minutes, burn about 15 gallons of fuel on a single run, which is only about 3.7 seconds. It's the fastest accelerating vehicle on land, and they're badass.
In a normal engine, combustion is controlled and predictable, but in top fuel racing, combustion borders on chaos as cylinder pressures, exceed 13,000 pounds per square inch, each combustion event trying to force the cylinder head off the engine block. One of the biggest dangers is detonation, where combustion becomes uncontrolled and pressure spikes violently in multiple directions at once, hammering pistons, rods, bearings, and cylinder heads with destructive force. An ordinary engine might survive mild detonation briefly, but a Top Fuel engine usually cannot, because the pressures involved are already so extreme that even a tiny instability can instantly crack pistons, lift cylinder heads, destroy head gaskets, split blocks apart, and sometimes detonate the entire engine from within. Too much fuel can be just as deadly as too little because nitromethane is injected in enormous quantities. And if liquid fuel accumulates faster than it can burn, the piston suddenly encounters an incompressible liquid during the compression stroke, a phenomenon known as hydraulic lock, where connecting rods bend, crankshafts twist, and the block itself can fracture under the force. This is why a single failed spark plug can destroy an entire power plant, because if one cylinder stops firing, unburned nitromethane rapidly accumulates until the next combustion event triggers catastrophic failure. And when that happens at full throttle, there is no warning, only explosion.
Line, that's all done within the first 3 minutes of coming back to the pit. Basically, we go over every part. We disassemble the engine, go through the short block, look at all the rod bearings, all the main bearings. Supercharger gets gone through. Basically, the rotors come out, strips, put back in. The heads get taken off, serviced. All the seats and everything looked at. Clutch comes out, new clutch pack goes in.
By the late 1980s and 1990s, blower explosions became one of the defining visuals of Top Fuel and funny car racing, as body panels erupted into the air and flames blasted through the headers like jet exhaust, while drivers like Kenny Bernstein, Connie Kalitta, Don Prudhomme, and John Force competed during an era where horsepower was rising faster than safety technology. The giant Roots-style supercharger mounted above the engine compresses enormous volumes of air into an engine already operating at the edge of structural failure. And if combustion escapes backward through the intake system, the supercharger instantly becomes a pressure vessel, and pressure vessels fail violently. Pressure builds inside the blower housing until the entire intake assembly detonates upward. Body panels explode off the car, flames erupt into the air, and blower restraints stretch violently trying to contain the blast, which is why modern dragsters use heavy-duty supercharger restraints and burst panels designed to intentionally fail and vent pressure away from the driver. The massive flames shooting from the headers are not just visual spectacle, but evidence that combustion itself is operating at the edge of control, because nitromethane burns slower than gasoline, and the engines run extremely rich fuel mixtures, meaning some fuel continues burning as it exits through the exhaust system. At night races, flames can appear yellow, orange, blue, or white depending on combustion conditions. And under full throttle, they can extend several feet behind the car while also contributing aerodynamic downforce, because the headers are angled upward specifically to help push the rear tires into the racing surface. Crew chiefs monitor flame behavior constantly because a sudden change may indicate a cylinder has stopped firing, allowing raw nitromethane to enter the exhaust system and dramatically increasing the risk of explosion. Even the rear slicks become part of the engineering madness because under more than 11,000 horsepower, the sidewalls wrinkle violently as the tire absorbs immense torque from the drivetrain, effectively acting like a second suspension system. Teams don't want perfect traction, they want controlled slip because too little grip causes uncontrollable wheel spin, while too much grip creates brutal shock loading known as dead hooking, where the engine RPM drops sharply and drivetrain components can physically break under the force. At high speed, centrifugal force physically stretches the tires outward, increasing their diameter and effectively changing the gearing during the run to help achieve higher speeds. But when traction becomes unstable, the result is one of the most feared conditions in drag racing: tire shake. The tires rapidly load and unload against the track surface multiple times per second, causing violent oscillations that blur the driver's vision, destabilize fuel systems, crack mounts, damage engines, and slam the entire chassis with destructive shock loads.
Whoa, big fire from Paul Lee. Lee's car erupts in flames as he goes across the racetrack, and now he's in front of JR. Look at, oh boy, huge explosion for Wilkerson. A massive backfire just before the 8th mile. Huge crash at the top end. Both cars involved, parts and pieces flying in every which direction. And Doug Kalitta and Tony Stewart skid to a stop. Oh boy, Beckman's across the drag strip and into the wall. A massive impact for Beckman as the right rear wheel has come off the car.
Oh, here we go. He's got a problem down there at the top, and he is getting over to the right side of the wall and has made contact. Wow, you could see it. And Justin Bond with an issue on the top end.
Drivers often abort runs immediately when severe tire shake begins because continuing can destroy the car or cause total loss of control at over 300 miles per hour. The dragster itself stretches nearly 25 feet long for one reason: control. The enormous wheelbase stabilizes the car during violent weight transfer at launch, helping prevent wheel stands while improving aerodynamic stability at extreme speed. Because above 300 miles per hour, aerodynamics become just as important as horsepower. The rear wing alone can generate thousands of pounds of downforce, forcing the rear tires harder into the racing surface, while even small aerodynamic disturbances can destabilize the chassis as the car covers nearly 500 feet every second. The clutch is another sacrificial component because instead of using traditional gear shifts, Top Fuel dragsters rely on a sophisticated multi-stage centrifugal clutch system that intentionally slips during launch to control how aggressively power reaches the tires. As speed increases, centrifugal force progressively applies more clamping pressure while generating enormous heat, often glowing red hot by the finish line, as clutch discs physically wear themselves away during the run. The clutch acts like a mechanical fuse, protecting the drivetrain from instant destruction because without controlled clutch slip, the rear tires would receive full engine torque immediately, likely causing catastrophic traction loss or drivetrain failure. When everything goes wrong, it rarely stays isolated because Top Fuel failures become chain reactions, where one instability triggers another until the entire machine begins tearing itself apart in real time. A spark plug fails, one cylinder stops firing, unburned nitromethane accumulates, cylinder pressure destabilizes, detonation begins, the supercharger backfires, the blower explodes, oil escapes, fuel ignites, and suddenly the entire car disappears inside a fireball.
It is Ida smoking the tires early. It is Brittany Force, 343.51. Ripping off the starting line, Ashley at 043. Huge explosion from Milliken.
Could be a championship-defining moment. They're 5 thou apart. Advantage Ashley.
While the driver is still traveling over 300 miles per hour with visibility gone, the cockpit shaking violently, and engine components physically exploding inches away. Yet even then, the driver still has to maintain control long enough to deploy the parachute safely. That is what makes Top Fuel drag racing extraordinary, because the driver is not simply accelerating, but surviving a controlled mechanical disaster in real time. Modern safety systems like carbon fiber cockpits, multi-layer fire suits, advanced restraint systems, onboard fire suppression, automatic fuel shutoffs, and parachute redundancy exist because every major accident forced the sport to evolve, allowing modern drivers to survive crashes once considered unsurvivable. After nearly every pass, crews completely rebuild the engine by removing cylinder heads, replacing pistons, inspecting bearings, checking valve train components, changing spark plugs, rebuilding the clutch, and analyzing data logs, because the forces involved are simply too extreme to trust repeated use. Entire teams swarm the dragster immediately after a run, performing what feels less like ordinary maintenance and more like battlefield repair, knowing the next launch will once again push every component to the edge of destruction. The engine fires, nitromethane floods the cylinders, the supercharger compresses air under enormous pressure, the clutch slips, the tires wrinkle, the chassis twists, flames erupt from the headers, and for less than 4 seconds, every component inside the car fights against destruction. Because Top Fuel dragsters were never designed to be comfortable machines. They were designed to convert controlled mechanical violence into acceleration more brutally than almost anything else on Earth. Every launch exists on the edge of catastrophe. Every successful run is proof that engineers, mechanics, and drivers have somehow managed to control forces violent enough to destroy the machine itself. And that is what makes Top Fuel drag racing so fascinating. Not just the speed, not just the flames, but the fact that for less than 4 seconds, human beings managed to control a machine fundamentally trying to tear itself apart. And sometimes, it wins.
Only thing that saved Steve Torrence was his reaction time.
He used a whole shot with.
Just putting on a show for the fans. God bless America.